From this constant search into tomorrow and the proven skills of today comes the Convair 880 jetliner, which will make possible profitable intermediate and short-range operations previously denied to jets. $50 million has already been spent on the 880 program, $10 million on engineering alone. By the end of 1958, another $50 million will have been spent. This is the heritage of the 880. Wingspan, 120 feet. Length, 130 feet, about the same size as existing four-engine aircraft. Speed, 615 miles an hour, the fastest jetliner in the world. Los Angeles to Chicago, 3 hours, 12 minutes. New York to Chicago, 1 hour, 31 minutes. Miami to New York, 2 hours, 9 minutes. It will operate from the existing facilities of over 350 cities serving the air routes of the world. Its versatility makes it capable of transcontinental use and even wide application to secondary intercontinental routes. For example, London to Rome, 1 hour, 48 minutes. Paris to Cairo, 3 hours, 35 minutes. Cairo to Tehran, 2 hours, 22 minutes. It is the first American-built jet transport designed specifically for intermediate range. A medium-range aircraft is subjected to more severe structural fatigue than a long-range airliner. Convair is 2 years ahead in this field of fatigue and vibration testing. 1/20th scale models of the 880 in perfect detail are built with watchmaker precision for wind tunnel testing. The models demonstrate the aerodynamic characteristics of the real airplane exactly before its first flight. The most advanced tooling and machine methods and equipment in existence are used to make 880 construction as economical and efficient as possible. Vast areas filled with machines capable of thousands of intricate metalworking functions. Machines of every type and size. Small ones, large ones, machines that require close attention, machines that are completely automatic, machines that without aid duplicate elaborate metal patterns, following a master form by mechanical touch or guided by a blueprint reading electronic eye, machines that drill, trim, cut, form, join, bend, and punch. Many of them Convair designed and patented, like this high-draw press. Cost, $750,000. Weight, 1,500,000 pounds. Its 7,000-ton pressures create in a single movement large components that formerly required time-consuming pre-assembly. One of the largest spar mills in the United States will be used for the 880's main wing spar. The world's largest radial draw former uses Herculean pressure of 75 tons to form the belt frames that will encircle the 880's fuselage. This one installation with related fixtures was made at a cost of $800,000. Metal to be formed is heat treated in this mammoth oven and then within a few seconds dropped into the tempering tank. This process gives 880 parts more strength with less weight. Hidden inside the 880's huge wings in every key fuel tank area where metal meets metal is a built-in miracle, a miracle called Scotch weld. Scotch weld is a revolutionary new bonding process developed by Convair and the Minnesota Mining and Manufacturing Company. Used with Convair-developed riveting, Scotch-welded wing elements have great fuel-tight integrity and added structural strength that other manufacturers have strived for years to build into their airplanes without success. Scotch-weld will give the 880 a leak-proof fuel tank system that will pay high dividends in trouble-free service and greatly extended aircraft life. Scotch-weld is the proven answer, and Convair has it now, at least 2 years ahead of the aircraft industry. The giant Scotch-weld curing oven, large enough to hold both 880 wings, is heated to carefully controlled temperatures to complete the bonding process. The 880 will be the only jet airliner with a great advantage of Scotch weld bonding, which makes it possible to use the whole wing as one huge fuel tank. An airplane can only earn while it's in the sky. Research, experimentation, and far-sighted design have cut turnaround to a minimum and given the 880 an earning potential 3 times as high as comparable 4-engine propeller planes. For instance, the engine pods are clamshell designed for quick access and removal, a package feature that greatly reduces maintenance and repair time. The CJ805 General Electric engines that will power the 880 have proven their ability in the B-58 Hustler. These lightweight units are the most advanced engines made, with the highest thrust-to-weight ratio yet achieved. General Electric has built more jet engines than any other manufacturer. The engine is lowered on a specially designed cart to be maneuvered easily to the maintenance area. Total engine replacement time, 30 minutes, far less than piston engine requirements. This package concept has been carried out all through 880 design. For example, left and right main landing gear units are interchangeable, cutting in half the operator's parts in stock cost. Convair's complete 880 customer support program includes such streamlined service as an integrated data processing system to control and simplify the handling, stocking, and ordering of spare parts and assemblies. Passengers on their first 880 flight will take for granted these standards of engineering excellence. Their first impressions will include the colorful interior decor by Harley Earl and Dorothy Draper, impressions of spacious and luxurious comfort. The 880 is the only American-made jetliner initially designed to offer 4 abreast seating, and passengers will enjoy the quiet and absence of vibration that is typical of jet flight. The cabin will be pressurized at sea level up to 20,000 feet and pressure equivalent to 6,000 feet at cruising altitude of 35,000 feet, well within the comfort range. A window for each seat gives superb visibility. Compact galleys provide delicious buffet meals, which can be enjoyed on folding desks. Ample storage room puts personal property at the passenger's disposal in flight. Luxurious appointments are everywhere in the 880 interior. Here is the 880's comfortable and friendly lounge area. Airlines can offer passengers a choice of an 88-passenger deluxe or a 111-passenger coach version, and the necessary seating change can be made in just 4 hours by a few men. This time-saving feature is typical of the attention given by Convair to details that will reduce the 880's out-of-service time and eliminate maintenance. The first 880 will roll out of the plant in November 1958. Chief Pilot Germerod makes his first test flight in the first part of 1959, and airline deliveries to TWA, Delta, Real Aerovias of Brazil, Transcontinental of Argentina, and Capital begin less than a year later. Many other domestic and foreign airlines are studying application of the 880 to their route systems. Regular commercial flights start in May 1960. The 880 is a direct result of the forward-looking research, development, and manufacturing skill that have made Convair a leader in the aircraft industry. The broad horizons of Convair engineering and manufacturing research and development have made possible great advances in meeting the rising standards and requirements of modern aviation. Because of the constant penetration into the problems of motion in time and space for the needs of tomorrow, Convair and General Dynamics have found superlative answers for the needs of today. One of these is the 880 jetliner.
This is the Convair 880 commercial jet airliner. More than 4 years have been devoted to developing and proving the 880 to make it the finest and safest modern jet transport possible. From 880 assembly lines now producing on a regular production schedule, 4 880 aircraft were specifically assigned to the test programs. 3 of these aircraft have been flying on regular test schedules. The other was assigned to ground tests here in the structural test facility. Its task was to demonstrate 880 ability to withstand the maximum flight loads it was designed to take. Rigged in these elaborate whiffletree arrangements, the aircraft was deliberately twisted and bent in a series of instrumented tests. Tests that were designed specifically to explore maximum designed loads in a program that simulated all operational extremes of flight through all types of weather. During these investigations, hard landings were simulated up to design limit loads. Engine pods and pylons were tested to extremes to simulate side gust loading, such as would be encountered in rough, stormy air. The fuselage was pressurized and deliberately deflected with massive loads to prove its ability to withstand forces that might be encountered during a pullout, such as would result from an abnormally steep dive. Typical of the tests conducted on the aircraft were those accomplished in the vertical tail areas. Diametrically opposed loads were used in a torsion test that applied maximum loads to the vertical fin in one constant direction, while at the same time, opposite loads were applied to the rudder. A test that explored strains that could be encountered during an engine-out condition. In tail fin bending tests, loads of up to 32,000 pounds were used to bend the vertical fin 15 inches off-center. A test designed to simulate maximum side gust loading conditions. Critical wing deflection tests were undertaken to simulate maximum wing loading, like the strains that could be encountered in a severe stall or pull-out maneuver. During this test, the wings were deflected as much as 6 feet, with loads ranging as high as 160,000 pounds. Downward deflection of the nose area was in excess of 1 inch, with over 43,000 pounds of load in this area. Aft section loading was 100,000 pounds, with a total downward deflection on the section of only 8 inches. The aircraft returned to normal following these maximum loads with no problems encountered. In each phase of the test program, the airplane was fully instrumented and results recorded for complete evaluation. The aircraft was engineered to exceed these test limits by 1.5 times the maximum design loads applied without sustaining any major structural failure. On assembly lines now producing 880s for delivery to airlines, an 880 was constructed to undergo an exhaustive fatigue cycling demonstration. It was installed in a special tank measuring 110 feet long by 20 feet wide. When filled to capacity for the test, the tank contains nearly 400,000 gallons of fresh water. In the investigation currently in progress and scheduled to cover more than a year, the fuselage will be continuously cycled underwater in a test that will simulate more than 20 years of first-line service operation. A system of hydraulic actuators are used to apply the strains that would be encountered during actual ground or in-flight operation of the aircraft. The fuselage was constructed complete with stub wings. Addition of the wings permitted full-scale examination of the fuselage, including strains produced in the wing root area. This is the first time that the combined fuselage and wing section of a commercial jet aircraft have been fatigue tested this extensively in the United States. The test is being run on a weekly basis. Approximately 5,000 cycles are completed each week. The tank is then drained for a thorough inspection and refilled for continuation of testing. Control of the test and recording of data is done in a structure adjacent to the tank. Here, through an electronic time-controlled cycle program, the fuselage is automatically put through a complete landing, taxi, and flight cycle each minute. Each 1-minute cycle simulates 1 hour of actual flight time. During the cycle, the fuselage is pressurized from 0 to 8.6 pounds per square inch internal pressure, well in excess of maximum in-flight operation pressures, and then back to 0 again. Stresses applied to the aircraft during various stages of cycling range from 1.22 to 1.85 times the pull of gravity. Daily inspections are made by specially trained crews of divers to ensure that no trouble could go undetected at any time. As a result of these tests, airlines purchasing the 880 will be furnished with inspection manuals that will contain information on the tests and serve as a guide for routine inspections for the life of the aircraft, in addition to ensuring that the aircraft will maintain its airworthiness serviceability through a full first-line lifespan of 20 years. More than 400 in-flight test hours have been completed by the 3 test 880 jet airliners involved in the program. The availability of these aircraft to meet flight schedules has been the best of any aircraft ever tested at Convair. 3 and 4 engine minimum takeoff performance and maximum effort landing investigations were conducted at the Air Force Flight Test Center at Edwards Air Force Base, California. These tests were conducted to determine takeoff capabilities at various weights and required runway lengths using both 3 and 4 engines. Minimum landing distances and rejected takeoff distances were also established. Over 200 stalls were completed in the program to determine slow-speed flying characteristics in varied configurations. Fuel jettison on the 880 is accomplished through 4 fuel nozzles located in pairs near the aft tip edge of each wing. The nozzles eliminate the customary extendable dump chute. They are permanently fixed with no moving parts and no maintenance requirements. The pattern is such that fuel can be jettisoned at all speeds without impinging any of the aircraft surfaces. Flow rates for the system were established as being well above those required. It is able to dump 51,700 pounds in a period of 20 minutes, 65% faster than minimum requirements. Each of the 3 test aircraft is specifically instrumented for the particular group of tests being conducted during any given flight. Basic data receiving equipment includes an airborne tape recorder for permanent record and a direct reading oscillograph. 2 photo panels containing all instruments pertinent to the test. A temperature recorder automatically keeps a record of temperatures in all areas of the ship throughout the entire flight. During flutter tests, telemetering is used. In these investigations, the pilot contacts the facility and initiates the test event by means of a countdown. All flutter flight activities are monitored here in the telemetering facility. Once a test has been initiated by the pilot, data is transmitted as it is produced on the aircraft to recorders capable of handling 20 separate data functions at one time. In addition to the permanent record, discriminators break the incoming RF frequencies into voltages that are graphically interpreted in visual form for an immediate quick look evaluation. With the test satisfactorily completed and tabulated, clearance is then given by the facility to the aircraft to continue to the next checkpoint. Both here in San Diego and at the Edwards Flight Test Facility, extensive testing was done on the thrust reverser system developed jointly by Convair and General Electric for the CJ805-3 engines that power the 880. Over 100 taxi runs were made to establish cascade settings that would achieve optimum efficiency. During all test flights completed by the three 880 test aircraft to date, no engine changes have been made as a result of engine failure. The 880 is now leaving production lines on regular schedules, ready for delivery. During the test program, it has proven its ability to land and take off well within performance predicted limits, and in level flights has more than met speed performance guarantees by demonstrating its ability to fly at its optimum estimated speed of 615 miles per hour. All Convair testing has been concluded, and emphasis is now shifting to final Federal Aviation Administration certification testing. Certification will be completed by spring 1960, with first deliveries beginning in November of 1959 to Transworld and Delta Airlines. This then is the Convair 880, the world's fastest jet airliner. Structurally and performance-proof, luxuriously appointed, versatile, the most advanced jet airliner available to the flying public today.
There's been a lot of talk about speed, but there can only be one fastest jetliner, only one speed champion. On its delivery flight, Delta's first Convair 880 became that champion, setting an ocean-to-ocean transcontinental record with an average speed of 665 miles per hour. But speed is only one facet of performance, and there are many ways to look at a champion in order to find out the many interesting things you want to know. Take an airline captain with 20 years' experience. His introduction is filled with technical details. How does she handle? How does she perform? That's what he wants to know. And the answer is as smooth as silk. On the ground, aircraft engineers and maintenance crews look at it from a different point of view. The trim, sleek lines, the sweep back of the sturdy wings are to them symbols of integrity, an integrity of concept, design, and structure. Looking more closely at the structure is, in a way, a preview of the 880's whisper-quiet cabin. Part of that quiet you can credit to the use of a thicker outer skin in keeping with the principle of integrity of design. Silent flight is engineered into an airplane's cabin. It can be accomplished by using a heavy aluminum foil sandwich with a special plastic backing. Then, over it, apply thick blankets of fiberglass insulation. Now add triple panel windows with air spaces in between. And then, round out the quiet engineering with a floating inner shell of panels that help exclude or help absorb nearly every bit of sound. And also credit a big assist from the powerful General Electric pure jet engines. The smooth turning turbines and compressors mean dependable vibration-free performance. And the integral sound suppressor, a daisy petal-shaped exhaust outlet, provides a tremendous reduction in sound level. But technical details are only a preliminary briefing to a more personal introduction to the jetliners with the fastest scheduled time of any jetliner, the one they call the quietest distance between any two cities. And ask Jim Thompson. A call between two cities can be interesting too.
Hi, honey.
Hi.
Everything's done. I finished the meeting sooner than I expected, and I'm on a Delta 880 flight, so we'll have dinner together.
Oh, I have to get my hair fixed before I pick you up.
You won't have time, dear. We're leaving in a few minutes, and the way traffic is, you'll have to start within half an hour.
Jim Thompson is explaining to his wife a present-day fact of life. With jet speed being what it is, most of us have to figure that it can take longer to go to and from the airport than it takes to travel 1,000 miles in the roomy cabin of your 880 jetliner. Forward of the main cabin is the club compartment. And as you relax back in your seat, you're ready for the wonder of your introduction aboard the fastest jetliner in the world. In that intimate but spacious club compartment, there is no speed sensation. The only sound you hear is from the air that is slipping by outside. The hum of friendly conversation is much the same as in your living room. And just the way it is at home. Don't let a member of the family give you too much good advice.
As a stewardess, I've served on a lot of different kinds of airplanes. But no plane has ever had the same appeal to passengers that these new 880s seem to have. Maybe it's because racks overhead are easier to reach. And maybe it's the special air conditioning that gives a uniform and pleasant climate anywhere they're sitting. Maybe it's because there's a certain home-like feeling in the cabin. But I guess it doesn't matter what the reasons are. The main thing is that all my passengers enjoy every minute they're on board. If there's work to do or just relaxing, time seems to float right by. So quickly, quietly, and so very pleasantly that anyone can rest without ever getting restless, even the very youngest generation. When we're on between-meal flights, many of our guests get added pleasure from a tasty snack. And, if they like, the cocktail of their choice, to sort of tide them over till they reach their destination. Of course, dinner time for some can be absolutely any time, and we tide those folks over too. Everything does seem easier when you can fly 1,000 miles in less than 100 minutes. Pure white, pure jet, pure luxury. And Mr. Thompson can't help wondering if his wife has run into some of the usual heavy highway traffic that might hold her back from arriving at the airport in time to meet his 880 that's already coming in to land. From way up north to way down south, people at the airports can recognize our 880s by their streamlined look and that pure porcelain white finish. But the passengers who fly on them can tell by 101 little things that one way or another, the speed and comfort of the fastest planes add much more than just a time advantage to their vacation or their business travel. And as a stewardess, you get to understand why parents find it easier to fly, or how much passengers appreciate thoughtful service and consideration on the ground as well as in the air. And you know why Mr. Thompson asked his wife to start out early when meeting his 880. Every year I travel almost 500,000 miles between a score of different cities, and one good thing is always true. Whether your passengers are 100,000 milers or if they're on their very first 880 flight, They all seem to feel instinctively that they're flying with the champion. And it's a feeling that they like.
At day's end, twilight sunshine seems to last a little longer in the sky. And cabin lighting, indirect, flows softly from behind the sculptured panels overhead. It's a pleasant time to travel because you know that in more than just a general way of speaking, you've almost reached your destination when your 880 leaves the ground. It's only natural for a youngster to take a lot of things for granted that those who've been around a little longer can appreciate more fully. For a man whose type of business can keep him on the go, speed has an extra special meaning that only those who travel often can truly understand. Evening time is meal time, too. And Royal Jet Service hospitality adds a certain flair to dining that makes you feel you're glad your appetite is healthy. And anyway, tomorrow is a better day on which to start the diet you made yourself a promise you would surely start today. There are 3 stewardesses aboard and twin buffets installed at each end of the cabin to help make the service even better. But here in the quiet of the cabin, there is no need for haste, although the world below is speeding by more than 10 miles in every minute. And there is one more thing to know about this champion of the airways, perhaps the one thing with the greatest meaning and most personal appeal. Because of its ability to fly in and out of intermediate-sized airports, the 880 will bring the benefits of jet travel to people sooner than they could be served by other jetliners. And therefore, to many people, in many places, the 880 is opening the door to the wonders of jet flight that have made travel by air today the most satisfying way of travel that we have ever known.